Hello third year, welcome back to our new topic, Nature's Chemistry. Today we are going to be looking at lesson 3, Fractional Distillation. Now you'll recognise that word distillation from our last lesson. Just to refresh your memories, distillation is a method of separating a mixture of liquids based on their boiling points. Our learning intention for today is for you guys to describe fractional distillation, and at the end of this lesson rather, you should be able to describe the process of fractional distillation and describe the properties and uses of different fractions. So first and foremost, what fractional distillation is and how we go about it, and second of all, what we use these different fractions for. So we use fractional distillation to separate out crude oil. Now crude oil is one of our 3 fossil fuels, and it is extracted from under the seabed at oil rigs and taken to these great processing plants where fractional distillation takes place. Now a fraction is a group of compounds with similar boiling points, and we use fractional distillation to separate these fractions out according to the boiling points of the substances in each fraction. So I'll say that again. Crude oil is a mixture of chemical compounds, mainly hydrocarbons, and we use fractional distillation to separate crude oil into fractions. Now each fraction is a group of compounds with similar boiling points, and each fraction is used for different things. So as each fraction has a different purpose and a different use, it's important that we are able to successfully split the oil into those fractions. So how does it work? So the oil is pumped in Scotland it's pumped in from the North Sea, and it is pumped into these big fractionating columns. These columns are massive steel towers, and inside the steel tower, the crude oil is heated to 350 degrees Celsius. So, the crude oil is pumped in here at the bottom. It's heat up to 350 degrees centigrade, and what happens is our lighter fractions, i.e. the fractions with the smallest molecules and the ones with the lowest boiling point, will vaporise first. They will go from liquid to gas, and they will begin to move up the tower. Now, as you can see on this tower, as we move from the bottom to the top, it gets colder. So at the bottom it's around 350 degrees, and at the top it's 25. So our lighter fractions, the one with the lower boiling points, will become gases first and slowly move up the tower until it becomes cold enough for them to condense, to go from a gas to a liquid and be collected through these different pipes. Now, each fraction has a variety of uses based on how easily they evaporate, how viscous they are, how flammable they are, and their boiling point ranges. Now, the fractions down the bottom of the column, so our bitumen for roads and roofs out of the residue fraction, our fuel for ships and power stations, which comes from fuel oil, they tend to be made of large molecules, and these large molecules have high boiling points. They're not very volatile. What that means is they don't become gases very easily. They don't flow very easily. They're very viscous, thick liquids. And they do not ignite easily. It's very difficult to burn these materials, these substances. Now, as we move up to the top, closer to our refinery gases, which are used as bottled gases, so for camping gas or for barbecues in the summer. Refinery gases are what's put in those bottles and what we use for barbecues, camping stoves, and that sort of thing. Now, these are very small molecules. They've got very low boiling points. They're very volatile. They become gases very easily. They flow easily. They're not very thick when they're liquids. And they ignite very quickly. It's very easy to set them on fire. They're very dangerous gases. So let's bring that together once more. So crude oil is piped into massive steel towers. At the bottom of the tower, the crude oil is heated to 350 degrees C. What happens is that the different fractions will vaporise and the gases will move up the tower. Now, as we move up the tower, it becomes cooler and cooler. Different fractions will condense, return to liquid at different points, and they will be collected in these trays and piped off separately. Now, these separate fractions have different uses based on their boiling points, how easy it is to ignite them, how flammable they are, is what that means, how thick the liquids are, and how easily they evaporate. Now, what I don't want you to do is I don't want this to go in one ear and out the other. So you are going to read the fractional distillation information card and complete this diagram here. I will provide a copy of it in the assignments tab, and I will make sure that the card, which I'm going to show on the screen in a second, is included in our virtual classroom for this week, so it's easy for you to find it. I'm also going to read through the card so that if any of you would prefer, you can hear me read the card to you instead of reading it for yourself. So here's what you're going to do. You are going to either read the card that appears on screen or listen to me read it and then complete this diagram. There will be a copy of it under assignments, and there will also be a version of this inside our virtual classroom so you can find it pretty easily. So here is our information card. You can pause the video here, have a read, and then fill out the diagram, or you can let the video continue and I will read through this. Crude oil is a mixture of chemical compounds, mainly hydrocarbons. Fractional distillation is the process used to separate crude oil into fractions according to the boiling point of the components of the fractions. A fraction is a group of compounds with similar boiling points. When crude oil reaches the refinery, it is heated until it evaporates. As the vapour, hydrocarbon gases, condense back into liquids, the column sorts the different fractions from each other and removes them from the sides of the column. The larger hydrocarbons with high boiling points turn back into liquids at the base of the column, and the smaller hydrocarbons stay as gases. They rise up the column and condense at different levels. At the top of the column, there are a number of hydrocarbons with low boiling points, between 20 degrees and 70 degrees, and these remain as gases. What you might also find useful for completing your diagram is this picture here. Shows a fractionating column, one of our big steel towers, and it demonstrates that the fractions collected at the top are our small molecules, those at the bottom are our larger molecules. It gives the name of each fraction, so at the top we have refinery gas, petrol, naphtha, kerosene, diesel, lubricating oil, fuel oil, and bitumen. It also goes through the various different uses for each fraction. For example, bitumen is used in roads and roofing. Lubricating oils Waxes and polishes come from our lubricating oil fraction. Naphtha is used to make toxic chemicals. And petrol is used as petrol in our cars, buses, and various modes of transport. So all the information I've just given you on these past two slides, you should be using to complete the diagram shown here. So we have now arrived at our summary of this lesson. And before we fully summarise, it is important that you know the difference between our small molecules, so our fractions that are collected at the top of the column, and our larger molecules, which are collected at the base of our tower. So small molecules don't have much attraction between them. They have low boiling points, are less viscous, they're not very thick, and they are highly flammable. It's very easy for them to catch fire. Bigger molecules have more attraction between them, so they hold together more, and this means that their boiling points are higher. They're more viscous, which means they're thicker liquids, and they're less flammable. Now, the larger the size of hydrocarbon in general means a higher boiling point. It means they are more viscous, they're much thicker liquids, and they are less flammable. So small molecules, low boiling points, not very viscous, highly flammable. Larger molecules, so as they get bigger and bigger, in general, their boiling points increase, they become thicker liquids, and they are less flammable. So remember, green man in the corner means we have to make a note of this. So if you've not got your jotter out already, get it out, pause the video, and write this down. And once you have done so, that is us arrived at the end of today's lesson. So I hope that we have described fractional distillation enough for you to understand how it works and for you to be able to describe it yourself. And I hope that our diagram labelling exercise has allowed you to explore the different properties and uses of fractions so that you could answer questions on it yourself. As ever, if you have any questions, please get in touch. I'm always available via email, as is your own class teacher. Drop us an email, post on the Teams, whichever suits you better. And I will see you all in the next lesson. Take care, guys. Bye.